Hi, welcome to another video on my Raspberry Pi with electronics, motors and propellers using pulse width modulation. Last time you have seen that I found to use a different multimeter than usual, a digital one instead of an analog one, because I can measure the frequency which I have to use to measure the effect of pulse width modulation. Then it turns out that the higher the pulse width, the lower the frequency, and vice versa. But it's a bit of cumbersome to do it with changing the value and compiling and restarting the program. So it should be possible, in my thinking, to not just put the value here, but to input the value by keyboard and have it done. So what I am going to do is, and since this is C++, I use cin. And ask for a PWM value. Now I'm not quite sure if this is going to work. So I am playing a little bit safe. Then I should change this and with end line. Then and here I have to do something else, because I have to create a variable. So what's more easy than to say integer PWM value and ask for that value here. Then say of course I don't want to be misunderstood, so I say 0 to 1024, and here I say PWM value. So let's see if this works anyway. Compiling. That works. Yes, and that's a good one. I put here end line, not end. So it goes to the yes, that's a very nice one. So I put here, let's say 125, and then it should give a quite high frequency. So let's go to camera and see whatever happens. So now I have changed the program and filled in a value for PWM on 125. So let's just measure that, and for that to do I can see with the potmeter completely turned down if I can measure something. I don't think so, by the way. So one probe here and let's say one probe here, and then it would be of course a good idea to put the multimeter right here so you can actually watch with me what the value is. One probe here, one probe again here. It says absolutely nothing. So let's turn up the potmeter. And of course I have to press it to have it make some contact. And then see if, yes, thank you, that works as well, with a little bit of persuasion. You may have noticed, by the way, that this LED, let me turn away the light for a bit, this is very weak blinking as long as the motor, this motor is working, which I discovered soon after the last video. So let me measure again. That's quite a different result. So with the potmeter on and everything running, it is clear that the frequency is at 10 kilohertz for a value of 125 at pulse width modulation. So let's change the value and see what happens. I set the value at 256. I've just interrupted the program and filled in another value. A very different value this time. It is climbing. But it's not getting towards 10. It is around 5 kilohertz. Alright, so let's put a different value. Um, 512. And I don't end the program because it asks for another value. However, I think that I should end the program and see for some, yes, because this is going higher. So now I end the program and say again 512. See what happens. Yes, it is at 7. So that is actually correct. Let's go back to 125, or the original value I've put in is 125, I think. Let me check back. Yes, 125. So now I should get 10 kilohertz or something like that. Not really. Around 6. Okay. But anyway, it is, I think, quite obvious that this is a success. I can use this very good. So let me get back to the program. After this measuring, it keeps asking for a new value, which is logical because it is a while in here. It keeps going on. And without me changing it, the value won't change. So let me now end this program and have a little change here, so that so it doesn't go to the next line. Just little cosmetics, I think. Okay. Yeah, just cosmetics. So if my conclusions are correct, then I should be measuring a rather low frequency now. So let me just off screen measure it. And yes, I get around 0.8, 0, 80, 85, 90. So that is correct. I go to 512. Now I should get a much higher frequency, which is 8 point whatever. And going down to 256, and I will be measuring something lower even. No, I don't. 7 point something. And going back to a very different value, 100. Then I get to 12. Around 12. So that does confirm what I thought. Yes. Another point is, of course, what value does it give? And that should not be different, because now I'm measuring behind, well, not behind the potmeter, but close to the second motor, and it should not be any different at the op amp side. So let me measure that as well. So with the slightly older program and with the frequency, or no, the pulse width modulation at 100, let me measure some frequencies here. the probe here again at the mass. Well, this is very odd. Not sure what to think of this. Going down, going up. Okay. And I did measure at the positive side of the motor there as well. Once again, here at the motor, here at the mass, it says clearly a rather high frequency, around 10. So what does it say here? Nothing, hardly anything. Hardly anything as well. Well, no. Toward 13. So this is rather peculiar. And well, I did not expect this exactly. This is going wild. Let me measure another point. What does it say here? Nothing. So 8. Around 8. So mass here, and I measure around this resistor, and it says 1. Where else can I measure? Well, here again. Let's go here. Near this resistor, it says 8. Oops. Yes, and I've pulled out the entire wire. So this should be here. No. Okay, where should that wire be? This is not good. This is the mass. I have to rewire, unfortunately. That was a rather simple rewiring. Just put it into the minus, into the mass. But the question is still the same. Why is that frequency odd? Jumping up and down. Mostly down now. I'm not sure. Okay, I have to get this one working again. Here it's quite high, quite according to the value. Let me change the value to highest value 1024. Should give a very low frequency. Yes. So it should give here a very low frequency. This really is a very low frequency now. So that is consistent. Well, mostly. So let me change back to, no, I'm not going back to 100, I'm going to 50. So now this value is not much higher there, around 12. So what is it here? $15. Jumping from okay, this is odd. From very low to very high. $14 now. $13. So in a way it is consistent. Frequencies are the same, but here it is jumping up and down. And I can't really explain why. And this motor is not consistent either, because it stopped again. And you can see hopefully the very fast, let me stop it, no pulsing, and now pulsing. So whether the motor is doing something or not, so does the LED. But that was not the topic of this episode. So let me see what else I can figure out. Okay. First, I moved the declaration of PWM value outside the while loop. It's done for a very practical reason, because otherwise it would declare the value, the variable over and over again, while now I can just do anything, and that is just for, well, not for cosmetics but for memory management. It's slightly better. What I thought to hear was that with the PWM value the frequency of the speed of the motor would change, but I can't hear that anymore, so I think it's not quite correct. What I also thought to discover is how to calculate, so I can calculate the frequency and have a formula. However, it takes two variables, actually three variables, of which two I do not know. To be correct, I do not know the value of those variables. The variable I do know is the system frequency, but that implies that I cannot check whether anything is as should. However, with this nice idea, I can check one more thing. Just go very low and see what value I get here, and I do that with the second motor since that is best to measure. And with 5 I get 3.5. Let me write something down. 5 gets 3.5. Yeah. No, it's not 3.5. It is 3.5 in kilohertz. So 3500 hertz. And now let me go again to 1024. And that is 11. So yes, one more frequency, 125. Then I think it's alright. One measure point and another. And that says, to my surprise, 11. And a measurable. So a lot of surprises, and this says 11, while with 125 I do expect something quite a bit lower. Anyway, was a nice experiment, recoding a bit and measuring. So for now, thank you for watching, and to be continued.